Hi, good day. I am Decadent Chef Aldrich Tigas, and me and my group mates will describe and discuss the different principles in ship handlings. Also, we will present the significance of deadweight, draft, trim, speed, under keel clearance, turning circles, and ship distance in ship handling.
Ship handling and maneuvering is defined as the art of proper control of a ship while underway, especially in harbors. Around docks and piers, it is one of the skills that any ship handler finds very satisfying when well accomplished. The most basic thing to be understood in ship handling is to know and anticipate how a ship behaves under all circumstances and what orders should be given in order to make the ship behave and move exactly the way you want her to. The difference between the ship heading and the actual direction of movement of the ship should also be constantly attended to us. This is essentially important at slow speed and when there are wind and current.
3 basic ship motion. First is longitudinal motion or forward or astern. A ship at sea moves in 6 degrees of motion: heave, sway, surge, roll, pitch, and yaw. Heaving is the linear motion along the z-axis, swaying is the motion along the transverse y-axis, and surging is the motion along the longitudinal x-axis. Second is lateral motion or sideways. Lateral movements typically apply stress and pressure at a constant rate along the length of the ship or the section of the ship which they are applied. Sea wave action that causes rotational movement does not move the ship as much the same wave action that generates lateral movements. So third is rotational or turning motion. Rotation refers to the motion of a body such that different points on it move at a varying speed depending on their position. Along the 3 axes, we obtain motions known as yawing, rolling, and pitching.
3 basic ship motion. Vessels also have other behaviors worth noting when their maneuvering equipment is in operation. Depending on the type of propeller, a ship with a single propeller will run ahead from stop pads to either port or starboard. When to put a stern from stop, the stern guns at the fast rate to port or starboard. When a ship has headway and the rudder is put over to one side, the boat turns to the same side where the rudder is turned. Thruster, on the other hand, move the vessel in sideways. Thruster, depending on its design, increase its effectiveness as the vessel slow down. Factors and forces that commonly constitute a change in a vessel behavior while being maneuvered. In external factors or forces, first is tide, second is sudden change in wind velocity and direction or gust, third is set and drift, fourth is the proximity of the other vessels, fifth is depth of our course. And in internal factors, forces under the control of ship handler, first is engine power, second is speed, third is effect of the type of propeller, fourth is rudder movement and type, and fifth is thruster, sixth is anchor and mooring lines, and last is tugboats.
Factors affecting ship's handling. One is human factor. Is a delay in time between your given order and the execution of the order will affect how you intend to move your ship. 2. Sudden breakdown or failure of the ship's equipment. 3. Mode of communication failure from the bridge to engine room or vice versa or to the fore and aft station. 4. Language problem. 5. Ship's momentum. What is deadweight? Deadweight is the actual amount of weight in tons that a vessel can carry when loaded to the maximum permissible draft. How to calculate deadweight? To calculate deadweight tonnage figure, take the weight of a vessel that is not loaded with cargo and subtract the figure from the weight of the vessel loaded to the point where it emerged to the maximum safe depth.
The draft of the ship's draft kills are deployed. Draft determines the minimum depth of water a ship or boat can safely navigate. Measuring the draft of any vessel is essential to ensuring a safe balance between the maximum load that can be stored away on board and the point at which the vessel is no longer stable. Trim. Trim is the difference between the draft forward and aft. When the forward and aft drafts are the same, the ship is said to be an even keel. Trim is an important consideration when loading and or ballasting the ship. The trim for ship describes its floating position in length, direction, namely as bow, or the aft of the ship is deeper submerged into the water. The trim can be significant impact on vessel's energy demand for propulsion during sailing.
Speed. An efficient regulation of vessels' speed and good knowledge of different speeds of different vessels and reasons behind them is necessary not only to follow rules and regulations of international conventions but also to make the vessels economical for the operator in the best possible way. Safe speed as per Call Regs. According to Rule Number 6 in Call Regs 4, every vessel shall all at times proceed at a safe speed so that she can take proper and effective actions to avoid collisions and be stopped with a distance appropriate to the prevailing circumstances and conditions in such cases. What is safe speed will depend on the vessels and circumstances.
Underkeel clearance is a vertical distance between the deepest underwater point of the ship's hull and the water area bottom or ground. That clearance should be sufficient to allow ships floatability in the most favorable hydrological and meteorological conditions. Underkeel clearance is to ensure safe navigation while approaching shallow water. It is the master's responsibility who must calculate precisely underkeel clearance requirements for the vessels and ensure that remains afloat all times. So the purpose of UKC or underkeel clearance is to maintain a minimum. UKC is essential for the safety of navigation. So that's all. Thank you for listening.
Turning circles. A turning circle is the radius of the circle about which a vehicle turns when it's steered. Its compact dimensions, excellent turning circles, and effortless handling combine to give it exceptional maneuverability. The ship handler, for instance, should be aware of how long it will take for a vessel to become stopped in the water from a full ahead position or how far the vessel will advance in a return. If a small rudder angle is employed, a larger turning circle will result with little loss of speed. However, when a large rudder angle is employed, then, although a tighter turning circle may be experienced, this will be accompanied by a loss of speed.
Stopping distance. Stopping distance is the distance by which a ship will continue to move after action is taken to stop engines until the ship comes to rest. Stopping distance details may be provided for sea speed, harbor speed, top speed, and etc. It may be provided for loaded and light condition.